Hi everyone, let's talk about today's LeetCode Daily Challenge. It's an interesting problem. It's a classic problem, kind of, if you know about some data structure that I will talk about shortly. So we are given an integer array of temperatures, and we are asked to see for each day, how many days should we wait until we get a warmer temperature? So for example, for 73, nothing. That's the last day, so it's 0. For 76, again, we don't have a warmer temperature after 76, so it's gonna be 0. For 72, we have two different options, and the one that comes first is 76, so it's gonna be 1 day. For 69, it's gonna be 1 day. For 71, it's gonna be 2 days because 69 is not warmer, but 72 is, so it's 2 days. For 75, it's gonna be 4 days, 1, 2, 3, and 4. And for 74, it's 1 day, next day. For 73, 1 day, next day. So this is a classic application of monotonic stack. That is exactly, if you search what is monotonic stack used for, it's gonna tell you it's used to find the closest bigger number that comes after the current number, or the closest a smaller number, so bigger or smaller. So let's have an example and see how actually monotonic stack is gonna help us here. So let's say we have we are looking at index I, and we want to see which one is the closest to I that is bigger than I, and we have 45 here. And as for the monotonic stack, let's say we have 30, we have 40, we have 50, 60, and 70. Okay, and this is our stack. This is the stack. Okay. And now we are looking to find the number that is bigger than 45 and comes after 45. So we look at the monotonic stack and we say, hey, 30, you are not bigger than 45. We pop it. And we look at the next one at the top of the stack, 40, it's not bigger than 45. We pop it, and now we arrive at 50. So 30 and 45 could be somewhere here, like 30 and like 40. Okay, and we popped them from the stack, and at some point we see 50. Okay, and now we know that 45 should choose 50 as the closest higher temperature. And then after we are done, after we know which one is the closest to 45, we are gonna push 45 to the top of the stack. So we add 45 here. Okay. Now let's talk about why this monotonic stack actually works. So if you notice, we popped 30 and 40. Why? So let's imagine we have some, I don't know, 25 here, like here. So this 25, for this 25, 45 is better than 30 and 40. That's why getting rid of 30 and 40, like, it's like a greedy choice. We say, you know what, 30 and 40, you are no longer relevant here. We have something that is bigger than 30 and 40. So if someone comes before 45 and needs a big number, it's gonna take 45. It's not gonna look for 30 or 40. Okay, so this is why it works. And if at some point we have like an 80 here, it's gonna pop everything from the stack, and it's gonna say, hey, 45 bigger than 80? No. 50 bigger than 80? No. 60 bigger than 80? No. 70? No. And then we add 80 to the stack. We add 80 to the stack, and what happens is that any number that comes before 80 now is going to refer to 80. Now it's going to find 80 and say, great. Any number that comes before 80 is not looking for 25, 45, 30, 40. None of these are relevant anymore because we found a bigger number, and that is the top of the stack right now. Okay, so we are going to write the code for this monotonic stack, and then I'm going to discuss another solution. If you don't know about monotonic stack, you actually can solve this problem with another method, another approach. Let's go and write the code for this one. So we need a stack. Okay, and we need a vector of integers to return. So it's going to be temp. Vector of int result of size n, and every one should be initialized to 0. Now we do a for loop from the end of the temperature. So for int I. And now what we do is we take the current temperature. And we go to the stack. We go to the stack and we try to find the first one that is bigger than current. And in the stack, we keep indexes. We don't keep the actual numbers because we need to find the difference between the two indexes. So we keep indexes. So while a stack is not empty and the top of the stack is less than or equal to current. So temp of st.top is less than or equal to current. Okay, we do st.pop. And after we have popped everything here, we check if the stack is not empty. We can say, you are my next higher temperature. So result of I becomes st.top minus I. And after we are done with everything, we push this current index to the stack, to the top of the stack. So st.push I, and that is going to be the index. That's it. And we just return result. And submit. Okay, now let's go back and see if we can actually solve this problem with a better approach. And to do that, you should notice the constraints of this problem. The temperatures are between 30 and 100. You can always ask yourself this question: why are the temperatures between 30 and 100? Why aren't they like 10 to the 5? And if you ask this question, you may, come up with some ideas. Let's go and see how that could be relevant. So let's say again here, we are finding the answer for index I something, and this I is like 40. Okay. So the question is that the next higher temperature for 40, what is the value of that temperature? It's going to be 41, 42, up to 100, right? So basically for this 40, we only have about 60 options. So if at this point, when we are iterating from the end, like from right to left, when we are iterating from right to left, and we have this data, we can actually iterate through them and decide which one is better for 40. And by that data, I mean, we know that 41 has happened at index, for example, let's say I is 10. And let's say 41 has happened at 13, the last time. 42 has happened at 15. 100 has happened at 39, and so on. And so for each value, for each temperature, if that has happened, maybe it hasn't happened. Maybe it hasn't appeared here at all. If it has appeared, we will keep track of the last one. And in that way, it's going to be easy for each I. We just do a for loop and check which one is closer to this index. Let's go and write the code. And when I'm writing the code, I'm going to explain more. So let's reset here. So we need, for keeping track of the numbers, of the temperatures and the last time they have been visited, I'm going to keep a hash map, for example, a map. So it's going to be map int last seen. Okay. And we need a result. So I need to define n. And a vector of result of size n. And now we do a for loop from the end of the temperature. So for here, first we need to get the current temperature. So now we should start from current plus 1 and go to 100. So the last one is 100. So for int other, I'm going to call it other, is going to be current plus 1. Other is less than or equal to 100. Other plus plus. And if last seen contains that, if it has appeared at some point, so if last seen that contains other, okay, now I'm gonna see, so int mean weight, I'm gonna define this mean weight to be some infinity, so equal, so the infinity should be something bigger than 10 to the 5 because that is the biggest distance between any two indexes. So I can define this at 2 million, something like that. So minimum weight, minimum days is going to be inf, okay? And here minimum days is going to be minimum of minimum days. And the last time this has appeared, last seen of other minus I, okay? Last seen of other minus I, that is where, like 15 minus 10, that is 13 minus 10. That's the index of this number minus the index of this current number. And we take the minimum of the two. And after this for loop is over, we know that we have tried every possible other number. So here we say if mean days is not infinity, that means we found something that was bigger than current. So we are going to say result of I becomes mean days. Otherwise, we don't need to modify result because it's initialized to 0. And that's it. So we go out of the for loop and we return result. And we get wrong answer. Okay, 0, 0, 0, 0, everything is 0. Okay, why? Oh, after we are done, we should update last seen. Okay, so last seen of current is going to become I. That means the last time we saw current number, this current temperature, this is at index I. Okay, and submit. All right, that's it. Please let me know if you have any questions, and also subscribe and like and comment, that's very meaningful to me. Thank you.